Welcome to the video on discrete and continuous random variables. So first we have the probability density for a continuous random variable. A continuous random variable is a variable that can take on any value, so including decimals and fractions. A probability density function is a function that shows the likelihood of an output. So you would use this for continuous random variables. The output will range from 0 to 1, because the probability can only range from 0 to 100%, and the area under the curve is 1, even if it's a piecewise function. So from 0 to 1 would be your outputs, and then your area is the integral from negative infinity to infinity of the function, and that has to equal 1. And we'll learn more about integrals in later videos, but basically what you need to know is that it's the area under the curve. To find the mode and median for a continuous random variable, you would find the mode by looking at the value where the probability density function is at its maximum. So if your function looked something like this, your maximum would be this value here. So whatever that x value is, that would be your mode. Your median is the value where the area below the curve from negative infinity to that value is 1/2. So we want to find where this area here equals 1/2. So in this, because it looks symmetrical, it would probably be your middle value. But if you had something like this, then it might be a value farther to the left. That would be your median, because that's where you would have half of your area. So your area would be 1/2. So next we have the mean, variance, and standard deviation for your discrete random variables and your continuous random variables. So your mean is equal to your expected value of x, and for a discrete random variable, that's going to be the sum of your x values times the probability of those values. For your variance, it's going to be the expected value of x squared, so you would do your x squared times your probabilities, and the sum of that, minus this here, which is your mean, squared. And then your standard deviation will be the square root of that variance. So to find our mean, we'll take each x value and multiply it by its probability. And then we'll add those together. So we have 0 times 0.2, which is 0, plus 1 times 0.5, which is 0.5, plus 2 times 0.1, plus 3 times 0.2, so that equals 1.3. Next, we need to find our e of x squared, so this would be 0 squared times 0.2, plus 1 squared times 0.5, plus 2 squared times 0.1, plus 3 squared times 0.2. So this equals 0 times 0.2, which is 0, plus 1 times 0.5, which is 0.5, plus 2 squared, which is 4, times 0.1, so 0.4, plus 3 squared, which is 9, times 0.2, which is 1.8. So this adds up to 2.7. So our variance is going to equal our e of x squared, so 2.7, minus our e of x, which is 1.3, squared. So 2.7 minus 1.69, which equals 1.01. And our standard deviation would equal the square root of our variance, so the square root of 1.01, which equals approximately 1.005. So that's what you would do for discrete random variables. For a continuous random variable, your mean is your expected value, which is the integral from negative infinity to infinity of x times f of x dx. So x is your value, and then your integral of f of x will give you your probability. So your variance is going to be your integral from negative infinity to infinity of x squared, because we're doing our e of x squared, times f of x dx, minus your mean squared. And then your standard deviation is once again the square root of your variance. So for f of x equals 1/8 x, and 0 is less than or equal to x is less than or equal to 4, your function would look something like this. So we go from 0 to 4. At 4, f of x is going to be 1/8 times 4, which is 1/2. So we know that this probability distribution works because the area underneath this curve is going to be equal to 1, because your area of your triangle is your base, which is 4, times your height, 1/2, and then you're dividing that by 2 or multiplying it by 1/2. So this equals 1, which is good. So our mean or expected value of x will equal the integral from negative infinity to infinity of x times f of x dx. So times 1/8 x dx. So this is the integral from negative infinity to infinity of 1/8 x squared dx, which equals 1 over 24 x cubed. And we're going to evaluate that from negative infinity to infinity, but this tells us that we're bound from 0 to 4. So we'll evaluate that from 0 to 4. So we have 1 over 24 times x cubed, so times 4 cubed, minus 1 over 24 times 0 cubed. So this is going to be 1 over 24 times 64 minus 0, which will equal 8/3. For your variance, we're going to need e of x squared, and we can go ahead and restrict our bounds to 0 and 4 right away. And then we'll have x squared times f of x, which is 1/8 x dx, which equals the integral from 0 to 4 of 1/8 x cubed dx. When we take the integral, we'll get 1/32 times x to the 4th, evaluated from 0 to 4. So that's equal to 1 over 32 times 4 to the 4th minus 0, which simplifies to 8. So that equals 8. So your variance equals e of x squared, which is 8, minus e of x, which was 8/3 squared. So that equals 8 over 9. So your standard deviation will be the square root of that, which equals 2 root 2 over 3. So that's how you would solve those problems. So next we have linear transformations to our random variables. So for transformations of the mean, we have our expected value where our data is multiplied by some number a and you add some number b. So to figure out your new mean, you could do a times your expected value of the original one plus your b value. For transformations of the variance, if you transformed your data by multiplying it by a and adding b, your new variance would be a squared times your original variance. So for example, a distribution has a mean of 24 and a standard deviation of 2. So mu equals our expected value of x, which is 24, and our standard deviation equals 2. What happens to the mean and standard deviation if you multiply the distribution by 4, then subtract 10? So for our mean, we would multiply it by 4 and then subtract 10. So 4 times 24 is 96, minus 10 is 86. So your new expected value is 86. So the new mean is 86. For our standard deviation, we need to convert it to our variance. So our variance is our standard deviation squared, which is 4. And then we'll do a squared times the variance. So 4 squared times our variance, which is 4. So this is 16 times 4, which is 64. So our variance equals 64. So the new variance is 64. So now we have our first IB practice question where the calculator is allowed. It says the probability density function f of x equals this piecewise function. Find the mean, standard deviation, and variance of the data. So our mean is our expected value, which equals our integral from negative infinity to infinity of x times f of x dx. So for this, we have two different functions, and then it's going to be 0 everywhere else. So for this first function, it would be our integral from 0 to 2 of x times 0.25x dx, and then we're adding our integral from 2 to 4 of x times 1 minus 0.25x dx. So this equals the integral from 0 to 2 of 0.25, which is 1/4 x squared dx, plus the integral from 2 to 4 of x minus 1/4 x squared dx. So this will equal 1/12 x cubed, evaluated from 0 to 2, plus 1/2 x squared, evaluated from 2 to 4, minus 1/12 x cubed, evaluated from 2 to 4. So that's going to equal 1/12 times 2 cubed minus 0, plus 1/2 times 4 squared minus 1/2 times 2 squared, minus 1/12 times 4 cubed, plus 1/12 times 2 cubed. And don't worry if evaluating these integrals doesn't completely make sense yet, because we're going to have a video going over that. So if we simplify all of this, we get 2. So our mean is 2. Now we need to do our variance. And to do the variance, we need our e of x squared. So that's going to be our integral from 0 to 2 of x squared times 0.25x dx, plus the integral from 2 to 4 of x squared times 1 minus 0.25x dx. So this equals the integral from 0 to 2 of 1/4 x cubed dx, plus the integral from 2 to 4 of x squared minus 1/4 x cubed dx. So we can take the integral and we'll get that. We have 1/16 x to the 4th evaluated from 0 to 2, plus 1/3 x cubed evaluated from 2 to 4, minus 1/16 x to the 4th evaluated from 2 to 4. So that'll equal 1/16 times 2 to the 4th minus 0, plus 1/3 times 4 cubed minus 1/3 times 2 cubed, minus 1/16 times 4 to the 4th, plus 1/16 times 2 to the 4th. We can simplify that to get 14/3. So our variance is going to equal our e of x squared, which is 14/3, minus our e of x, which was 2 squared. So that equals 2/3. So our variance is 2/3, and then our standard deviation is going to be the square root of our variance. So that'll equal the square root of 2/3, which equals the square root of 6/3. So it's the square root of 6/3, which is approximately 0.816. So here's your solution to this problem. Now we have our second IB practice question where the calculator is allowed. It says the Smiths' monthly expenditures for 2020 have a mean of $3,532.12 and a standard deviation of $325.34. In 2021, they moved to a new city where the cost of living doubled, in addition to $300 of additional monthly expenses. Find the new mean and standard deviation for their expenses. So we have our expected value of x is 3532.12, and we have an e of 2 times x plus 300. So this is going to be equal to 2 times our expected value plus 300. So we have 2 times 3532.12 plus 300, which equals 7,364.24. So that's the new mean. To find the new standard deviation, we need to look at our variance. So our variance is our standard deviation squared. So it would be 325.34 squared, which equals approximately 105,846.12. So that's our variance of x is 105,846.12. So we have our variance of 2 times x plus 300 is going to equal 2 squared times our variance of x. So that's 4 times 105,846.12, which equals 423,384.48. To get our standard deviation, that's going to be the square root of our variance. So it'll be the square root of 423,384.48, which is 650.68. So the new mean is 7,364.24, and the new standard deviation is 650.68. Which, if you notice, your standard deviation is just the original standard deviation times our a value, so times 2. So in summary, a continuous random variable is a variable that can take on any value. A probability density function is a function that shows the likelihood of an output. To find the mode, you'll find the value where the probability density function is at its maximum. To find the median, you'll find the value where the area below the curve from negative infinity to that value is 1/2. For a discrete random variable, your mean is the sum of your x values times their probabilities. Your variance is your expected value of x squared minus the expected value of x squared, and then your standard deviation is the square root of that variance. For continuous random variables, your mean is the integral from negative infinity to infinity of x times f of x dx, and your variance is the integral from negative infinity to infinity of x squared times f of x dx minus your expected value of x squared, and your standard deviation is the square root of that. For transformations of the mean and variance, when you transform your mean, you'll multiply it by the a value and add the b value, and when you transform your variance, you'll square your a value and multiply it by your initial variance. That's all for this video. Thank you for watching.